Hey friends, welcome to the YouTube channel all about electronics. So in the previous videos of the vector algebra, we have seen that how to do the vector addition and the vector subtraction mathematically as well as the graphically. So in this video, we will learn about the vector multiplication. So whenever the two vectors a and b are multiplied, then the result can be a scalar or the vector, and that depends on how they are multiplied. So based on that, there are two types of multiplication. One is the dot product and the second one is the cross product. So in case of the dot product, the multiplication operation that is performed on the two vectors is represented by the dot symbol. While in case of the cross product, the operation that is performed on the two vectors is represented by this cross symbol. So first of all, let us start with the dot product. So if we have two vectors a and b, then their dot product can be represented as this ax bx plus ay by plus az bz. So as you can see, here both vectors a and b are multiplied with each other component wise. So this is the one way of representing the dot product. Similarly, this is the another way of representing the dot product. So let's say here we have two vectors a and b and the angle between them is equal to theta AB, then their dot product can be given as the magnitude of A times magnitude of B times the cos of theta AB. So let us understand what this dot product signifies. So here this dot product is the commutative. That means we can say that this A dot B is same as the B dot A. And as per the definition, we can say that is equal to b times a times cos of theta ab. So here if you see, then this a cos theta ab is nothing but the projection of the vector a on the vector b. So it signifies that how much one vector lies in the direction of the another vector. So if the dot product of the two vectors is positive and the angle between them is also acute angle, then we can say that the two vectors are on the same side. And as the theta increases, then the projection of the vector A on the vector B reduces. So whenever this theta is equal to 90 degree, then the dot product will become 0. So we can say that whenever the dot product is equal to 0, then the two vectors are perpendicular to each other. On the other hand, when the angle between the two vectors is equal to 0, then this A dot B will be maximum value. And that will happen when the both vectors are parallel to each other. Likewise, when the dot product between them is negative, then the angle between the two vectors will be obtuse angle. And in that case, we can say that both vectors are going in the opposite direction. And whenever the angle between the two vectors become 180 degree, then this A dot B will become maximum negative. So that will happen when both vectors are antiparallel. So basically, from the dot product we can find that how the one vector lies in the direction of the another vector. So here we have seen that the projection of the vector A on the vector B is equal to A cos theta. So let's call it as the AB. So this AB is known as the component of the vector A along the vector B. So now let us see how to represent this projection in terms of the dot product. So we know that this A dot B is equal to magnitude of A times magnitude of B times cos of theta AB, right? So similarly, this scalar component AB can be represented as this A dot small ab, where the small ab is the unit vector in the direction of the vector B. So as per this definition, we can say that this A dot small ab is equal to A times this AB times cos of theta AB. And as the AB is the unit vector, so its magnitude will be equal to 1. So we can say that this AB is equal to A cos theta AB. And as you can see, as it is just the magnitude, so this AB is the scalar quantity. That means this AB represents the scalar component of the vector A along the vector B. So similarly, if we multiply this component AB with the unit vector AB, then we will get the vector component. So we can say that this vector component AB is equal to this A times small ab times small ab. And that is how, using the dot product, we can find the scalar as well as the vector components of this vector A along the vector B. So apart from that, if we know the two vectors A and B, then with the help of the dot product, we can find the angles between the two vectors. So let's say the two vectors are the vector A and the B. So we have seen that as per the definition of the dot product, this A dot B is equal to A times B times cos of theta AB. Moreover, we have also seen that this A dot B can also be found by multiplying the vector A and the vector B component wise. So from this expression, we can say that this cos of theta AB is equal to A dot B divided by magnitude of A times magnitude of B. So we know that how to find the magnitude of A and the B. So here the magnitude of vector A can be given as the square root of ax square plus ay square plus az square. And similarly, this magnitude of the vector B can also be given as square root of this bx square plus by square plus bz square. So here, if we put the values of all these three equations in this expression, then we can find the value of the cos of theta AB. And from that, by taking the cos inverse, we can find the angle theta AB. So let us take the simple example so that it will get clear to you. So let's say the A is equal to 2ax minus 4ay plus 7az, and likewise this vector B is equal to 5ax plus 3ay minus 8az. And let's say we want to find the angle between the two vectors. So for that, first of all let us find the A dot B. So we know that this A dot B can be given by this expression. So here this ax times bx is equal to 2 times 5. Similarly, this ay times by is equal to minus 4 times 3. And likewise, this az times bz is equal to 7 times minus 8. So then after, if we add all these products, then the A dot B will come out as minus 58. So similarly, let us also find the magnitude of the vector A. So that is equal to square root of ax square plus ay square plus az square. So here it will come out as square root of 2 square plus minus 4 whole square plus 7 whole square, and that is equal to square root of 69. Similarly, the magnitude of the vector B can be given as square root of 5 whole square plus 3 whole square plus minus 8 whole square, and that is equal to square root of 98. So in this way, we got the value of the A dot B, the magnitude of the A, and the magnitude of the vector B. So now let us put all these values in the above expression and let us simplify the above expression for the theta AB. So we can say that this theta AB is equal to cos inverse of this A dot B divided by the magnitude of the vector A times magnitude of the vector B. So that is equal to cos inverse of minus 58 divided by square root of 69 times square root of 98. And if we further simplify it, then this theta AB will come out as 134.8 degree. So from this we can say that the angle between the given two vectors is equal to 134.8 degree. So in this way, with the help of the dot product, we can find the angle between the two vectors. So similarly, now let us see the cross product. So unlike the dot product, the result of the cross product is the vector quantity. That means here, we will perform the cross product on the two vectors, then we will get the another vector. So first of all, let us understand what this cross product signifies. So let's say, if we have two vectors A and B, and if we take the cross product of these two vectors, then the resultant vector will be the perpendicular to the plane containing both vectors A and the B. Now this perpendicular vector can have two directions. That means it can go outwards or it may be coming inwards. So the question is how to find this direction. So the direction of this vector can be found using the right hand screw rule. So as you know, when the right hand screw is turned clockwise, then it will go inwards, right? And whenever it is rotated anti-clockwise, then it will go outwards. So here, to find the direction of this resultant vector, first this screw is placed perpendicular to the plane containing both vectors A and the B. And then it is rotated from the vector E towards the vector B. Because here we are finding the A cross B. And as it is rotated anti-clockwise, so it will move outwards. Or in other words, it will move in this direction. So we can say that the cross product of the vector A and the vector B will be perpendicular to the plane containing both vectors A and B, and it will be in this direction. So in this way, using the right hand screw rule, we can find the direction of the resultant vector. Now on the other hand, instead of the A cross B, suppose we find the B cross A, then once again the resultant vector will be the perpendicular to the plane containing both vector A and the B. But now its direction will be opposite. So let us find its direction with the help of this right hand screw rule. So once again, now let us place this screw that is perpendicular to the plane containing both vectors A and the B. And now let us rotate it from the vector B towards the vector A, because here we are finding the B cross A. So now if you see, then it is rotating in the clockwise direction, and therefore it will go inwards, or in other words, it will move in this direction. So as you can see, the resultant vector of the B cross A is in the opposite direction to the A cross B. So we can say that this A cross B is equal to minus B cross A, or in other words, this B cross A is equal to minus A cross B. So now we know that how to find the direction of the resultant vector after the cross product. But as we know, the vector also has the magnitude. So here the magnitude of the resultant vector will be same as the area of the parallelogram that is formed by the vector A and the B. So as we know, if the A and B are the two adjoining lines of the parallelogram, then the area of the parallelogram can be given as this A cross H. And here this H is equal to B sine theta AB, where the theta AB is the angle between the vector A and the B. So from this we can say that the area of the parallelogram is equal to this A times this B times sine theta AB, and we can say that this A cross B is equal to AB sine theta AB times small a n, where this AB sine theta AB is the magnitude of the resultant vector and the small a n is the unit vector that is perpendicular to the plane containing both vectors A and the B. And once again, its direction can be found using the right hand screw rule. That means if we have two vectors A and B, then mathematically their cross product can be expressed like this. But using this expression, if we want to find the resultant vector, then first we should know the angle between the two vectors. And moreover, we should also know this unit vector, right? And suppose if we have been given the two vectors A and B, then from that it is difficult to find both of them. So there is another way of finding this cross product. So let us see that. So if you have the two vectors A and B, then their cross product can be given by this determinant. So if we solve this determinant, then this will be the first term. So this can be found by cross multiplying these two terms, that is AYBZ minus AZBX. Likewise, the second term will be equal to minus AY times this AXBZ minus AZBX. So once again, it can be found by cross multiplying these two terms. And likewise, this third term is equal to AZ times this AXBY minus AYBX. So once again, for that, we can cross multiply these two terms. And in this way, we got the expression of the A cross B. So let us take the simple example to understand it more clearly. So let's say the A is equal to 2AX plus 4AY minus 7AZ, and likewise the vector B is equal to 5AX minus 3ay plus 8az. So here we can find this a cross b with the help of the determinant. So for that, in the determinant, let us put the value of this ax, ay, az as well as the bx, by and the bz. That means here the ax is 2, ay is 4 and the az is minus 7. Likewise, the bx is 5, by is minus 3 and the bz is equal to 8. And now if we further simplify it, then the first term will be equal to 8 times 4 minus 3 times 7. That means the first term is equal to 32 minus 21 times ax. Likewise, the second term is equal to 8 times 2 minus 5 times minus 7. That is equal to 16 plus 35. And for the second term, we will have this negative sign. And likewise, the third term is equal to minus 3 times 2 minus 5 times 4. So that is equal to minus 6 minus 20 times az. And if we further simplify it, then we will get this 11 times ax minus 51 times ay minus 26 times az. So in this way, we can find the cross product of the two vectors. So now, for the two vectors a and b, we know that their cross product can be given as this ab sine theta times an, right? And from this we can say that the magnitude of the cross product is equal to ab sine theta ab. And one would say that from this it is also possible to find the angle between the two vectors, because from this expression we can say that this theta ab is equal to sine inverse of the magnitude of the a cross b divided by the magnitude of the vector a and the b. So yes, it is possible to find that, but with some caveats. So let us understand that. So here we already know that how to find the magnitude of the vector a and the b, right? And here this a cross b can be found with the help of the determinant. So once we get that, then it is easy to find this angle theta ab. So to understand that, let us take the same example which we took while finding the angle between the two vectors using the dot product. And let us also compare the results with what we got during the dot product example. So here, this is the expression for finding the angle between the two vectors using the cross product. So as per this expression, first we need to find the a cross b. So this a cross b can be found with the help of this determinant. So for that, in this determinant, let us put the value of this ax, ay, az as well as the bx, by and the bz. So after putting the values, if we solve this determinant, then the first term will be equal to this 32 minus 21 times ax. Likewise, the second term will be equal to minus 16 minus 35. And during the second term, we will also have this negative sign. Likewise, if you see this third term, then that will be equal to 6 minus minus 20. That is equal to 6 plus 20. So if we further simplify it, then we will get this 11ax plus 51 times ay plus 26 times az. So now let us find its magnitude. So its magnitude can be given as the square root of this 11 square plus 51 square plus 26 whole square. And if we further simplify it, then it will come out as 58.29. So similarly, let us find the magnitude of the vector a. So that will be equal to 2 square plus minus 4 whole square plus 7 whole square. And that is equal to square root of 69. And similarly, if we see the magnitude of the vector b, then that will be equal to the square root of 5 whole square plus 3 whole square plus minus 8 whole square. And that is equal to square root of 98. So now let us put all these values in this expression. So we can say that this theta ab is equal to sine inverse of this 58.29 divided by the square root of 69 times square root of 98, and that is equal to 45.2 degree. That means here, with the help of the cross product, if we try to find the angle between the two vectors, then in this case we are getting the 45.2 degree. But if you see the earlier case, then with the help of the dot product, the result that we got was the 134.8 degree. So let us understand what is the issue and why we are getting the different answers. So as you know, this sine theta can also be given as sine of 180 degree minus theta, right? That means here the sine of 45.2 degree will be same as sine of 180 degree minus 45.2 degree, and that is equal to sine of 134.8 degree. That means here instead of the obtuse angle we are getting the acute angle. That means the sine function can give us the two results in the range of 0 to 180 degree, and that is why instead of the obtuse angle we are getting the acute angle. Moreover, here we are also taking the magnitude of this A cross B, so that will be always positive, and that is why instead of the obtuse angle here we are getting the acute angle. But that is not the issue in case of the dot product. So if you see, then in case of the dot product, we are taking the product of A dot B. So it can be both positive as well as the negative. And moreover, the cos function gives the unique value in the range of 0 to 180 degree. So that is why with the help of the dot product, we are always getting the correct angle. So we can say that if you want to find the angle between the two vectors, then the dot product is more reliable method. And we should find the angle between the two vectors with the help of this method. Alright, so that being said, now let us see some of the properties of the cross product. So as we have seen earlier, this cross product is not commutative because this A cross B is equal to minus B cross A. Similarly, it is also not associative. That means here, for the three vectors A, B and the C, the cross product of the A with the B cross C will not be same as the cross product of the A cross B with the C. But this cross product follows the distributive law as well as the scaling laws. That means here, this A cross B plus C is same as the A cross B plus A cross C. And similarly, the cross product also follows the scaling law. That means here, if we multiply the vector A with some scalar k and then we perform the cross product with the B, then the result will be same if we perform the A cross KB. And here, since the k is scalar, so we can take it out. So we can also write it as this k times A cross B. Now another important property of the cross product is that if we multiply the cross product with itself, then the result will be equal to 0. On the other hand, in case of the dot product, if we perform the A dot A, then we will get the A square. But here, this A cross A will be equal to 0. Now in case of the cross product, we also know that the resultant vector is perpendicular to the plane containing both vectors A and the B. And the direction can be decided using the right hand screw rule. So as per that, this AX cross AY will be equal to AZ, where the AX and AY are the unit vectors in the direction of X and Y. Similarly, this AY cross AZ will become AX, and likewise, this AZ cross AX will be equal to AY. That means using the cyclic permutation, we can find the result of the cross product between the unit vectors. That means here, this AX cross AY will be equal to AZ, and similarly, this AY cross AZ will be equal to AX, and likewise, this AZ cross AX will be equal to AY. But if we move other way around or in the anticlockwise direction, then the result will be negative. That means now, this AY cross AX will be equal to minus AZ, and likewise, this AZ cross AY will be equal to minus AX, and similarly, this AX cross AZ will become minus AY. So that is the property of the cross product. On the other hand, if you see the dot product, then the dot product of the two perpendicular vectors will be equal to 0, because in that case, there will not be any projection in the other direction. But on the other hand, if we take the dot product of the unit vector with itself, then the result will be equal to 1. That means here, this AX dot AX is equal to 1, and similarly, this AY dot AY and the AZ dot AZ is also equal to 1. So these are the properties of the dot product and the cross product. Now so far, we have seen the multiplication of the two vectors using the dot product and the cross product. So similarly, let us see the multiplication of the three vectors, that is a, b and the c. So we know that when we perform the dot product of the two vectors a and b, then we will get the scalar quantity, right? So once again, we cannot perform its dot product with the another vector. So we can say that we cannot have this a dot b dot c in case of the vectors. That means for the three vectors, there are two possibilities for the multiplication, and one of them is this a dot b cross c. So first, the result of this b cross c will be equal to vector, and then after, when we perform this dot product, then we will get the scalar quantity. That means the overall result of this multiplication will be scalar, and that is why this multiplication is known as the scalar triple product. Similarly, the another possible way of multiplication is a cross b cross c. So here, once again, this b cross c will give us the another vector, and once again, when we perform this cross product, then we will get the vector. That means in this case, the result of this multiplication is the vector, and therefore, this multiplication of the three vectors is known as the vector triple product. So one by one, let us see them. So for the three vectors a, b and the c, their scalar triple product, that is a dot b cross c, can be given by this determinant. And as you know, in case of the determinant, the cyclic permutation of the rows will not change the determinant value. So therefore, we can say that this a dot b cross c is same as the b dot c cross a, and that is same as the c dot a cross b. So in this way, with the help of the determinant, we can find this scalar triple product. And as we have seen, the result of this scalar triple product will be scalar quantity. So similarly, let us see the vector triple product. So if we have a three vectors, that is a, b and the c, then their vector triple product, that is a cross b cross c, can be given by this expression, that is equal to b times this a dot c minus c times this a dot b. So here, just notice that this c times a dot b is same as this a dot b times c, because here the result of this a dot b will be scalar, and as it is the scalar quantity, so it can be multiplied before or after the vector. But here, just keep in mind that this a dot b times c is not same as the a times this b dot c, because in the first case, we are taking the dot product of the a dot b, while in the second case, we are taking the dot product of this b and c. So that is why these two are not same. So it will get more clear to you when we take few examples related to it in the next video. But I hope in this video, you understood about the dot product and the cross product. So if you want to visualize the same thing in the 3D space, then for that, I have given the link in the description. So for more information, you can check that link. So now in the next video, we will solve some examples based on the dot product and the cross product. So if you have any question or suggestion, then do let me know here in the comment section below. If you like this video, hit the like button and subscribe the channel for more such videos.